Okay, shadow on 3. 1, 2. Good morning and welcome to my shop where I'm about to start work on this radio. I've got my assistant here with me. Oh, Shadow, how many takes do we have to do? Come on. Okay, I'm just carrying on. So here's the radio I've got to work on. I received this radio just a couple days ago from a man who was considering throwing it in the garbage, but I think it had a little bit too much sentimental value. He couldn't bring himself to do that, and somehow he found me and said, here you go, have a radio. So I don't know anything about it. I think it's working, but I'm not sure. Clearly there's a problem here, that's for sure. In fact, let's see if we can get this out of here right now. Take a look at this. So this is loose for a reason. It's all warped and curled. Wow. Okay, so we don't want to bend this guy, that's for sure, or crack. That's a bit of a problem, that's for sure. Okay, as for the radio, watch out, Shadow. So this is the Fanshawe clip to clip the antenna to. It's not meant to hold the power cord like this at all. That's not what that's there for. That's actually the antenna clip. Okay, let's take a look. Start right here. This has not been done correctly. This is done in the way that it's on its way to a short. In fact, this one is on its way to a short. Fair bit of string in there, but also there's bare wire going right down, and one good yank on this and bring them right into contact. Maybe not, but sooner or later that's just not right. So we'll straighten that out. Why is this here? I don't know. Wire's cracked. It's cracking. Like that along its whole length. Can you hear it? I'm gonna hold this up near the microphone and bend it so you hear this. My finger. You hear some fine cracking anyway. Yeah, this cord is shot. Yeah, it's just cracking everywhere I bend it. That's also why it's probably taped up here. These are all danger signs. When you see stuff like this, these are danger signs that something's going wrong there. Danger, 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 Shadow. Okay, Shadow, this is the part where you talk. Okay? Shadow, you gonna talk now? Shadow doesn't talk. She doesn't like to be held. She's a little independent cat. The other cat wants to be on my lap all the time. But this cat, no. She's an independent investigator. Doesn't follow the crowd. Does her own thing. Doesn't really care what others think. Who am I talking about? Let's see what's in here. Caution, caution. Disconnect power cord before removing cabinet back. I go even further. Inspect power cord before doing. Radio receiver model C600. 280 milliamps. That's its drain. 25 or 60 cycles. Got a big X down here with part of the X missing. This is suggesting there's an antenna on the back of this. We're going to find out in a moment though. This also suggests it, but let's see. It's all the way out. These are machine screws going into plastic. This is probably Bakelite. It doesn't look like it to me, but I think it must be Bakelite. I don't think if you put machine screws into regular plastic, it doesn't happen. So yes, there's an antenna on the back. Yes, okay, so there's probably screws that hold this to the radio. Maybe not in this case. Okay, I'm going to leave that floppy and get the radio out at this point, because I can't do any more. Oh my god, this is a dust. Oh my god, there's a flood of dust in there. Wow. Look at this. Yeah, this is like one of the dustiest radios I've ever seen. Oh my gosh. Okay, what's going on here? So I don't think the chassis is screwed in the cabinet at all. Take this guy out. How's that supposed to stay on there? The other one looks good. Oh, you know, it's not supposed to stay on there. It's supposed to stay on here. Yeah. Well, that's easy. That's easy to fix. That'll be easy to fix. Pull this guy off. Okay. Slide him out the back. There is something holding it in. Maybe there's one screw. Yeah. One screw. It's like the green Roberts. It's like a label that used to be on the bottom, probably with the tube layout, is missing. Okay, speaker's not coming out with it. Speaker wires are just done with connectors here. That's nice. I like that. Okay. Bring it out a little further. There we go. What are you looking at, Shadow? She's looking right at me, that's what she's looking at. Okay, quick inspection of the cabinet. Maybe not so quick. There's little bits and pieces of that warped plastic in there. Bits and pieces fall. There's the tube lineup, and what is it? 12 SK two 12 SKs, 12 BE6. 12, I can't quite read it, SQ7, 35, oh my gosh, it's just so small, 35 Z5, 35 L6. That's 1, 2, 3, 4, 5, 6 tubes. Get you the 120 volts. Let's take a look at the radio here just before I do any more. Oh my god, it's just, wow, where's this been sitting? The dustiest places in the world. Yeah, finish with the cabinet here, Jim. Is there any cracked corners or anything like that? The cabinet appears to be in excellent shape, actually. You can see darkening up in here, all up in here. And that's above, if you look on the radio, that's above the rectifier tube and the output tube. That's where the heat is in this guy. So this is an indication of mileage. This radio has been played a fair bit at one time. We're looking for any serious damage or cracks, in particular cracks. I want to know about them right away. This feels solid. So this is cracked here. What is this? What is that? There's a crack there, crack here, crack here. What happened here? Comes right through. It's very odd. Yeah, I'm pretty sure this is Bakelite. It's got the right color and everything. For sure it's Bakelite. Jumps the value of the radio up. That speaker's on that's a metal plate there. That's surprising. That's a little bit of money. That makes this thing really strong in the front here, I think. Feels like it. Feels like it's as strong as can be. Can this come off? screws, but the thing about turning screws like this in something like this is there's a good chance the screw will just crack the plastic, or in this case the big light. So they formed in these things here that take the screws. Something similar maybe down under here. Yeah, I can feel them. And if you've done any of this amount of work, you know certainly with plastic there are times where you'll turn the screw, and instead of the screw coming loose here, this piece will break off at the bottom. Now this is different. This has got an attachment all the way down the side. But in other cases it's just like a plastic tube you're screwing into. The tube cracks and you're in trouble trying to fix the radio after that. So that's why you wouldn't want to jump in and start doing this. Now I may take that back because I see the lock washer is missing on this screw. And that tells me somebody's been there and done that. Somebody's already had this off. So chances are the screws can't come off. Okay, get rid of the cabinet. Good, that's good. That's a big test. A nice sounding radio in a really ugly cabinet. That's not quite right. What about this now? What have we got here, Shadow? You're still here. What do you think of this? Shine some more light on it. Well, it's got all its tubes. Oh man. Oh man. That is frozen solid. That is just frozen solid. Wow. So this hasn't been tuned for a while. I see the capacitor is closed, but the pointer's in the middle. So light bulb back under there. That looks like a 120 volt light bulb back there too. So these radios that do not have a transformer have a number of things about them you need to know right away. One is, especially with a non-polarized plug, there's a chance that this chassis will be live at 120 volts when I plug it in. And I don't want to get into this in too much detail because it's a complicated topic, and if you're curious about the hot chassis problem, I say to you, read up on it on the internet. There's lots of fantastic information, but this is certainly a radio that has the capability of having a hot chassis. That's a chassis that is connected directly to one of the power lines. So be aware of that. Number two, if it doesn't have a transformer, it has a hard time supplying power to a light bulb. So there's a trick that's played with the rectifier tube, actually this one here, rectifier tube, to produce cheaply, literally cheaply, 6 volts to make a light work. Those radios, when you turn them on, the light goes on bright, and goes dull, and goes up, and goes down, which is a neat thing in itself, but actually that's an artifact of the technique they're using to supply the bulb. In other radios like this without a transformer, where it's hard to supply the bulb, they just go ahead and supply it at 120 volts. That's what I think is going on in this radio. It's good to know this, because if you think the light is only 6 volts, you might be a little reckless while you're handling it or something, and then find out, oh, it's not. So stuck shaft, probably just lubrication to free that up. Pointer in the wrong place. That's probably from the stuck shaft, or maybe this is stuck too. Ooh, that is stiff. No surprise. I mean, look at the thing. Look at the thing. Clearly one of the steps here is to just clean this baby up before doing much else. Let's look at it on the side here. This is going to be a little... Or maybe I'll just hold it for now. Okay, there's a great big light bulb. Oh, okay. What is going on under here? This is on the... It's on the side of ugly. Well, somebody's done something here. That has been stuck in. That has been stuck in. I'm really quite sure they're not original. This thing, I've never seen a capacitor look like that. That is scary looking. I'll have to take a closer look at that thing. Never seen one look like that. So all the original parts and lots of tired old capacitors in here. 1, 2, 3, 4, 5, 6, 7. Gotta count these ones. 8, 9. Might as well count them. 10, 11. 11 tired old. I probably missed one in there. It's the kind of radio I'd be very hesitant to plug this in and turn it on. Obviously with this, I'm not about to plug it in with this guy. But even I'd be hesitant to even replace the cord and plug this guy right in. Somebody's worked on it. There's question marks in my head about what's going on with all this tape here. Yeah, this is not one for plugging right in. There's the big honking light bulb. Nope. And these aren't easy to replace either. Probably in the end, if I do it, I will think about putting some kind of like LED light or something in there other than this. Bring it out front here. Yeah, I don't have these. Look at this. This is a bayonet style. Oh, look at that double pronger on the bottom. Probably burned out. Okay, now. Yeah, I think it's just some brutal cleaning first, and we'll get this moving. The tubes are coming out when I do the cleaning, so we'll run the tubes through the tube tester, and we'll see where that's at. Can power this radio up with shop power supplies, things like that, rather than plug it right in. I have to replace the cord. 2. Even and then what are the chances of it working with all those old parts? Really small. One in there that's scary looking. Okay, too much dust in here. Shadow, you're just gonna stay the day. Alright, so Shadow, you just gonna stay the day here? She's pretty happy on my bench. Maybe it's because the door closed behind her. She's stuck in here now. Okay, onward. I'm pretty sure if I turn on the vacuum, there will be a cat flying through the air here. So I have my vacuum ready, but I don't want to turn it on. So let's get the tubes out. $35 Z5. They're coming out easy. 50 L6. I thought it said 35 L6. 50 L6. A 50 L6 and a 6 tube radio. Does that work right? 50 L6? Where was that sticker? Let me take a closer look. You can't necessarily be swapping those tubes around. Let's just take a look here. Magnifying glass to see it. 35 L6. So with a 50 L6, this radio won't work right. In fact, I think that's a significant mistake. Unless a dropping resistor was removed, but the thing is, there wouldn't be a dropping resistor. Let's add these up. That'd be 35 and 35 is 70, and then 12, so 70 and 50 is 120. So you can't go putting a 50 in here because that's another 15. So you need 135 volts. That can drop the voltage on all the tubes to a level. And I'm continuing to teach myself about the details about tubes. And something I never realized is that it's not wise to operate a tube at a reduced filament temperature from what it's intended for. I just thought, the less voltage you put on the tube heater, the less hot it is, the less everything, the less wear and tear, the less everything. No, there are metallurgical concerns in the cathode. And at certain temperature ranges, there are metallurgical effects that you don't want happening. Oh. It's got a grounded shield on it. Okay, I haven't seen that in a radio like this. 12BE6. And what was this one? 12SQ7. Okay, I'm sure these are all correct. Now the rectifier tube and the output tube are the two tubes that would regularly get changed in a radio like this during its life. 12SK7, the last one is supposed to be a 12SK7 too. So this radio has 6 tubes. That means it's almost certainly this one right here. Oh, 12SJ7. Almost certainly this is a good performing radio when it's working well. Oh, that's a silly statement, isn't it? No, this one has the potential to be a good performing radio because it has this RF tube in the front. Well, what can I do, Cat? I'm going to have to turn on the vacuum here. I'm going to have to take the radio somewhere else in the house and vacuum it. You look so comfy, cozy up here. Still awake? Yeah, as much as the cat is awake. Well, I'm going to stop for a little while because I don't want to disturb my cat with the vacuum. Okay, even I wear ear protection when I run my shop vacuum in here. It's a little vacuum, but it's a small room. So, okay, cleaned it off, and now what do we see under all that dust? That was a lot of dust. See some kind of bad things here. This looks a little like moisture got on the end of this. I mean, I can't imagine somebody sprayed water on it or anything like that, but what causes these kinds of shapes? Condensation? Why is there this? Oh, it says top. So someone was concerned about the polarity of these wires going in the speaker, and of course on the other side of the output transformer there is no concern for that. You don't really need to know which one's on top. And in a lot of cases these wires are doing it. They'll tell you. As long as you don't move them around too much. Maybe I'll leave that there for now. They hang where they are supposed to go. Don't do that. That's stupid. Yank the wire on the transformer. Not a good idea. Okay, anything work better? No, not at all. What's next? Yeah. Look at the ball. I've never seen ball bearings look so. They look like they haven't done any bearing for a long time. Wow. I can already see one of the plates is bent out on this capacitor. Another whole issue I want to explore at some point. Point coming soon. Let's start with this piece down here. And you get an old radio like this, you might be asking yourself, oh wow, is this too far gone? Is this too far gone? And it's hard to say. Look at that, it just came free, just came loose like that. All the back tension is gone. So it all came from there. All of it. Well, let's see. Is the capacitor moving? Is everything moving now? The string is just spinning around the shaft there. Or the shaft is spinning. Oh, it almost got a grip. Because this is still pretty tough. Yeah. Oh my gosh. That's just locking right up. Yikes. Give it a really good shot. This is the back bearing. Get my touch. And then we have these grounding contacts here. Wow. So something is tightening up. Just that the pointer is reaching this? No. This is not rotating. string has pretty good tension on it. A little bit there. What's doing that? Why is it jamming up like that? It's not the pointer, is it? No. I can feel the string tense up. I have to guess it's the capacitor that's doing that. Wow. See if I can move this on the string. Yeah, move it down here. These plates are rubbing so hard. Well, that couldn't be, could it? That would be the end of this. Hey, 1, 2, 3 sets of plates. That's another indication that this is actually a high-performing radio when it's working. This is really bad. Well, it can't be this anymore. When it's far-fetched that it's this pulley, the string just slides around this thing, and there's nothing else in there except this sliding back and forth, and that's free. So we're left with this has to be that bad. How can it be that bad? Like, I know you can't feel it, but you can see the whole capacitor frame is twisting when I'm turning it. Can I just power it past that? I really can't tell what it is. You can hear the string tighten up. There's a hint there. The string is tightening up. The string is not done right. How have they done the string? So the string is done. This looks original. The string is done with I don't know what they call this, a double pull. If both ends come in tied together, and both ends on the spring. A lot of these radios, they tie one down and the other one has the spring on it. This one's got both. In some radios, as you tune them, the tension on the string varies and the spring expands and contracts to accommodate it. Maybe because of things happening with the string in here, or I don't know why that actually happens, but it does. You can see the tension going up and down on the. So what's happening? Is the string expanding as I go back this way? Oh, what did I just go past? I just pushed it past something. This is what it comes down to, fixing a radio. Oh my gosh, this is just terrible. Figure that out. I just get the feeling we're going to hear swang. And so the string is climbing out of its bobbin here. It's climbing up on the shaft. That's going to increase the tension a little bit. There, it just did what it's supposed to do and skidded back. I got it all the way to here. Just slowly get bolder and bolder with things like this. Oh, it just feels terrible. What is doing that? Now, what could happen that it would come to a spot and just really tighten up a lot? Right in here, too. Oh, now the tightening's back here. What's going on with this thing? A possibility is the shaft is driven so hard on this that the capacitor's the shaft can't turn because this is too hard. Now, if I can kind of squeeze this open slightly and see if the tension changes. I've never tried that. I haven't got any tool that would easily push these apart, but just a little bit would make a big difference. I do have some tools. I have a tool right here. I don't know if I can push it hard enough to make any difference. My finger's in the way now. I'll tell you what I can do here. Yeah, a little bit of an awkward thing. Okay. Oh, it didn't seem to loosen anything up. I don't know if that was in any way successful. I'll have to turn the screw to discover what is going on here. These screws are often, like these are locked down. These are locked down. Don't really want to take the antenna off. Not much options here. There we go. I don't want to put too much force on that. So I don't normally fool with these parts on a capacitor. I wouldn't recommend it. Because let's give it a try. Oh, that came loose as easy as could be. That was surprising. Yeah. Well, that must have changed the tension. No. So it's not coming from the shaft. To take the string off. Well, that's another thing I don't like doing, but it's got to be done. Oh, it's as free as can be. Come on. All that was the string? What the heck is holding the string back? Certainly not this. Okay, so maybe I did this just nice enough I can put the string back on. Ooh, this is an old string. It's an old radio. What do you expect, Jim? So what's left? That must be that pulley. Come on, it can't be that pulley out there doing that. Fix that up pretty good. Okay, so it takes a bit for the tension in the string to get down in the mechanism, so it's back to being as stiff as can be. Okay, this guy who I just kind of wrote off here, it must be really gripping the string or something. It's kind of weird how they have it on this shaft. Definitely an odd arrangement. Is the string supposed to skid over this plastic thing? Is the plastic thing supposed to rotate? On the volume control shaft. I think that's the problem. Okay, so this may not be the most suitable place for WD-40, but put a little in there. No, that loosened it up. My gosh, that's what it was. And the last thing I would have thought. The last thing I did think. Okay, put the pointer roughly in the right place here. it is roughly in the right place. That's the end of the capacitor. Somebody's put a mark there. A little more subtle mark would have been nice. Look at how this has all been cleaned, but look at it. It's not in very good shape. I think that's its real color, this kind of light color. The light is right behind this metal plate. So it's supposed to throw light kind of upwards through here, and then just generally through the plastic piece. Let's take a look at that for a sec. It's probably not as bad as it looks. Well, I mean, it's really curled up in here. The pointer is shaped for the roundness here. This is filthy. The words are definitely on the back. It's just plastic, right? General Electric. It's held in the radio. It must be held in the cabinet. And not held here, but held in the cabinet. Probably some clips. I don't know why it's off. Find that out later. Well, I've got all the tubes out. I think I should give them a test. Okay, let's start with the 35Z5 rectifier tube. This is all set already, but let's just double check. So 35 on the filament. 07003 07003 0610 0610 23 here. Okay. Now plug them in. Switch on. There we go. Well, it's warming up. And we'll perform the short test. Look for shorts between the tube elements. And watch the pointer. If the pointer rises to a significant degree, we have a significant short. So the rectifier tube is pretty important to verify this stuff. And to some degree it's protecting the tube tester. E is correct. E is correct. I'm going to push the button. Rectifiers and diodes. The rectifier should come above. It says right there, rectifier is okay above that line there. Now we're going to do a voltage check of the line, only because people get upset if I don't do this. This is a fairly heavy drawing tube, so I have to crank it up a little bit. Here we go. Fantastic. Okay, nothing wrong with that tube. Great. Now the next tube is the output tube. It's also a high voltage 50. It definitely is a 50L6, which is the wrong tube for this radio. But probably the person who put it in knew he could get away with it. We'll have to make a decision about switching this with a 35 if I even have one. So 50L6. I'll just leave the camera rolling because I know some of you really enjoy watching this stuff. So 50L6. 50 volts, signal 8. That's a large signal. 18H. It's a high bias. 18H. 07345. 07345. 50L6. 0610 0610 43. That's the cheater. See, I say that's the cheater because that's a vernier, and the guys who built this, when they're all done, they can go like this and go, yeah, that looks good, I like that. Okay, what's the number? That's what goes on the chart. 43. Do they really do it like that? I don't know. See, well, the recheck point is 1000. 1000 on here is where my finger is. we're ready. In she goes. Saw the light flicker a bit, which means the heater's going to work. Give it a moment. Now the fact is, really, tubes that haven't been operated for a long time can easily have some gas that has built up in them. Not because of a leak through the glass shell, but because components in the tube are breaking down very slowly. So those gases that could be in the tube present a problem. First, the tube is designed to eliminate those gases, but it takes time. I'm actually letting the tube sit here and get hot. There's a reason for that. And whether this is an important issue with a tube like this, I don't think it is. I think it's a much older tubes where you need to think about this. Sitting around a long time, gases develop. What you want to do is heat the tube up without applying any voltage on the plate. If you apply voltage on the plate, electrons start screaming through the tube towards the plate, and on the way they strike these gas molecules and ionize them. And then the ionized gas molecules are attracted to the cathode. And when they hit the cathode, they begin to contaminate it. Basically, it's almost like plating it, although I don't think it is. I think it's different. I don't think it's electroplating by any to any degree. But nevertheless, reactions are occurring, and the cathode, which is one of the life issues in a tube, the cathodes are wearing out while the tubes are operating. You're just going to pollute it, ruin it, do something bad to it. So the solution is you heat the tube up and you leave it for a long time with no B plus on it, kind of like what I'm doing here. The problem with this whole explanation is that I haven't read yet how long it might take for the tube to correct itself. And what's actually happening, I might as well finish off this discussion here. Let me grab this tube. So if you look at a glass tube, you can't see this on a metal tube, you'll always see this shiny area on the tube. Sometimes it's on the side, this one's right up on the top. And that is a chemical that has been, using a tricky technique, has been blasted onto the inside of this tube late in the manufacture of the tube. And that material blasted onto the side of the tube is there to pick up gas molecules that might be floating around inside the vacuum here. Not only right after manufacture, but maybe primarily right after manufacture, but during the life of the tube, this stuff is constantly collecting gas out of the tube. The thing is, it doesn't work very well at room temperature. It needs to be heated up. So you need to operate the tube, let it rise up, the glass shell has to rise up, you're heating this material up, and then you have to let it sit for some length of time, and I don't know what that length is. I don't know if it's seconds or weeks, I don't know. Again, not probably an issue with this vintage of tube. So I'm going to show you one now where you can see that material, this is called the getter, has gone white. When it's gone white, that indicates it's finished its chemical reactivity. It's been consumed. And it no longer has any more gas eating power. Oh, there's two of them on this tube. One on each side. So this tube is shot. We can be sure of that. But you can look at this tube all day and not see any hint as to where a leak might have occurred. There's no damage on it, the shell is tight. So this could be from internal gassing. And it could be from this tube laying around somewhere for 40 years. Slowly, components inside, there's probably plastic in there somewhere. I don't know. I'll show you another one. Again, all white on the top instead of that shiny. And why? Well, this tube's not in very good shape. Okay, this tube's not likely to test well. But you can see the material's just turned completely white. There you are. If you don't know about this stuff, there is a lot to know about vacuum tubes. They are fascinating things. Here's some simple descriptions we've all been told. Pictures of electrons flying through space, striking the plate and all that. Those pictures are not really accurate for what is really happening in the tube. It's much more complicated and much more interesting and not so well understood as you might think. So, having said all that, having left this on long enough, let's see if it's any good. Output tubes. Output tubes take a beating. So, short check. No shorts. For this tube, it's just above 1,000, so it's got to come up to here. It's good. And I can hear somebody calling. Are you calling me? Yeah. Come on. You're wondering where Shadow is. She was in here earlier. I don't know where she is now. Yeah, I don't know. Whoa. What are you saying? I'm saying come out. That's what that low call was, a firm message to me. Come out of the shop. But I'm in the middle of doing this. So I think what I'll do is I will stop and play with the poor cat for a while, because that's what has to be done. And we'll carry on with the tube testing when I get back. In the meantime, I'll just leave this on. Why not? After that long speech, I should leave this on. Hey, there's no voltage on the plate of this tube until you push the test button. Peanut, I'm coming. Okay, cat's all happy again. The tube's been in there for a while. Let's just test it again, just to see. We get a slightly lower number. When I do tube tests, I think like most people, I just do them. Most people, yeah, everybody when they do their tube tests, I do it pretty quick. I don't leave them in the tester for a length of time. I'm pretty quick, just to kind of get through it. Never really thought about leaving them in the tester for a long time or anything like that. Okay, so now we're going to do the 12-volt metal tubes. 12 SQ7 is what's next. Let's change this right away. Don't make a mistake there. 12 SQ7. And interestingly enough, you can jump the current up in one of these tubes in the heater quite a bit. Surprisingly enough. I'm just losing my mind here. There we go, 12 SQ7. Okay. Right 1 18L 25100 25100. I don't think I finished my thought there, did I? 3760. 60. Sensitivity 37. F. 12 SQ7, 12 SQ7. 13, 13. In you go. Now this has got two tests because this guy is the detector. So there's actually two tubes in one. Amplifier and two diodes, I believe, are in there, sharing the same cathode. Okay. That's good. So this tube should come up above 760. We're testing the triode part of it. The 760 is way down here. Good. Now the diode part, 2013P. 2013. Oh, heavens, P. I got the tube in there. P. So some tube testers you can get away with doing this with the tube sitting in there. This one you can't. 0760. 0760. You know, I'm going to take that, what I just said, back. I think all of them, you have to make sure the heaters are set right before you put the tube in. I think that's probably makes more sense. 48, concentrate, man. This is where I lose my concentration. I make a big mistake. Also why I do a lot of double checking when I'm doing this. Filament, diode, 2013, 2013P. 2013P 076000760. Yeah, making these videos, it really does break my concentration. When I'm in here not working with the video going, it's a different experience. Still make all the same mistakes though. We're ready. No shorts. This one is a diode. And there's 2 plates to test. Push this button and it only has to come up this far. First one. Oh, okay, that was yeah, what can I say about that? Okay, I think we're warmed up. That's good. That's 1 plate. Plate 2. Right button. It's good too. So 2 was good. Okay, that's great. 2 more to go. Next one is the 12SJ7. Don't see too many of those. 12SJ7. 12SJ7. Now I think that's the RF amplifier. So I'll bet you the 12SJ7 has some particularly attractive things about it for being used as an RF amplifier in that position. 25L. Stop talking, just concentrate here. 17251. 17251. 4630. 4630. 45. C. Pentode. 1020 is what we expect it to come up to. Voltage 13. I think I have a lot of these in my tube collection. If I remember right. There we go. Very good. And now, just above 1,000. Okay, let's double check everything. This tube is cold. 12SJ7. When I plug it in, watch the pilot light. Yeah, it's dipping just a wee bit. So that's how I check to see if the filament is drawing. The filament draws enough current to make the pilot light dim a touch. Let's check all these things. 225L. I do make a mistake doing this stuff. 17251. 17251. 4630. 4630. The classic way to make a mistake here is when you're not looking, the roll chart rolls ahead just a touch. It just rolls like that, and then you're over here reading numbers again. It's easy to make a mistake. The mistake was I pushed the GM button. That's a mistake I made. I made a mistake. Let's try it again now. Is my head screwed on tight enough? I think so. Well, that's not very good anyway. Now let's double check everything again. I monkeyed around too much here. I'm out of the general, lane of procedure. I'm off track. Yeah, that'd be the word for it. 12SJ7. 17251. I did this. 17251. I'll do it again. 4630. 460. We're about to condemn a tube, so I want to make sure I got it right. 45C. Wait a minute. Man, I'm all over the map, aren't I? Did I not drink enough coffee? This is just an amplifier tube. I should be pushing the GM. Ah! 2,000 on the GM. It's supposed to be 1,000. Okay, I've tested the daylights out of this tube. It's good. It's a goodie. A bit of a rough road in the tube tester there. 12SK7. Okay, very, very, very common tube. 13, 2, 10L. 17251, 17251, 4630, 4630. So I can actually pop it in place of the other tube. You have the same arrangement, 44, same pin arrangement, and C. Yeah. So these tubes can be popped, can be, well, you have to look into it more carefully, in particular radio you've got, but it looks like these two tubes can be swapped. Swappable. No doubt there's differences, but it looks like you could swap them. This is supposed to come up to 1520. That's way up, right in the middle. Whoa! What's wrong? How did that go over that far? That's crazy. Okay, double check everything again. 12SK7. 10L. Yeah. 17251. 17251. I did say these were the same as the last settings. 4630. They are. 44. Everything is correct. See, everything is correct. That's a whopper. Double the GM that it should that would have at its rejection point. I guess I better say that right. There we are. All tubes tested. No. We got one more. Got an oddball here. The 12BE6. Odd because it's glass and the other ones are all metal. 12BE6. B. 12B. Oh my gosh. Alright. 12BE6. 13.4 on the signal. 8L. 8L. 51763. 51763. 3000. 2000. 12BE6. 51763. 51763. 3000. 2000. 41. Sensitivity. C for the plate. Whole tube tested. 1570 is the reading on the GM test. Saw the pilot light flicker. So there's a couple kinds of tube testers. There's probably more than two, but there's two primary types. This is a dynamic tester. So this one actually has a technique for actually measuring the transconductance in the tube. Other tube testers measure basically the strength of the cathode. Is really what they're kind of measuring, just by setting the tube up and then seeing how much current will flow through it under their test. Though the GM of a tube is not fixed, the GM of a tube depends upon how the tube is operated to a great degree. That means when you read the GM on these charts down here, the expected GM or things like that, or even in a tube manual, you pull out a tube manual and it gives you the GM. It's the mutual conductance at that operating point or that operating condition that they have the tube in. So different testers will show different GMs. If they even show a GM number, I think this is actually rated. It just says rejection point, but and then the GM. Yeah, I won't talk anymore. That tube's got to be warmed up by now. I won't talk anymore. Okay. 12BE6, 1570. So just past the halfway mark. Way over. You know what's going on here? Maybe my line is a little high now. No, not really. That's not going to make that much difference. Ooh, what was that? Let me give 2 readings there. Unsteady. I think that's my tube socket in this tube tester. They wear out. Good. So, you know what the bottom line is? All tube's good. All tube's good in this radio. Okay, so that little exercise is over, and honestly, yeah, there seems to be 2 kinds of radios that come into my shop. Ones with perfectly good tubes, and ones with a bunch of faulty tubes. I never understood how you get a bunch of faulty tubes. I'll just turn this upside down. Okay, next idea here with this is pop in the tubes, and it is in such bad shape underneath. We could, for fun, use a power supply in the shop here and raise the beat plus on the radio, with the tubes actually not operating, with no heater, not plugged in, or not plugged in. Just raise the beat plus and see how much, see what happens. That might be fun to do. Yeah.